Here's your Unit 7 Exponent Quiz Review, explained. For Part 1, you're going to simplify. Your answer should contain only positive exponents. For number 1, I noticed that it is a multiplication problem, and the base of 8 and m is the same. We learned that the rule is that we would keep the base and we would add the exponents. If I don't see any exponents with some of our bases, those are invisible ones. So for our 8s, there's 2 of those, so it's 8 to the second power. And for our m's, there's 1 m in our first set and 3 m's in our second set. So 8 to the second power, m to the fourth would be our answer. And we could go one more step and do 8 to the second power, 8 times 8, which is 64. So you could also express this as 64 m to the fourth. Okay, so note that if you don't have an exponent, there's an invisible 1 there. Let's take a look at number 2. Now for number 2, our coefficients, our numbers are not the same, but we do have the letter r's and they do have exponents. So I'm going to handle my coefficients first. So I just do regular math with that. A negative 8 times a negative 6, a negative times a negative is a positive, and 8 times 6 is 48. And then I'm going to go ahead and handle my r's. When the bases are the same and we're multiplying, we keep the base and we add the exponents. So this would be r to the 5th. Next, I see a negative 6, a positive 6, and a negative 3. Those are all different bases, so I'm not going to apply the rule. I'm just going to do multiplication on those. So I'm going to do negative 6 times negative 3. And all of that equals 108, a positive 108. And now for my x's, I do see x to the second and then just a singular x. So I'm going to put the exponent of 1 there to remind myself. For my x's, when the bases are the same and we're multiplying, we keep the base and we add the exponents. So for our x's, we get 2 plus 1 plus 3, which is 6. So x to the 6th. Moving on to number 4, I see that our coefficients, our numbers are different. So I'm just going to do regular math with those. I'm going to do negative 6 times 8, and that's going to be a negative 48. But my bases of x are the same, x to the 4th, and then just x, which means x to the 1st. So x to the 4th plus the 1. So I keep the base and add the exponents. So that is x to the 5th. Okay, so remember, if you have a variable by itself, the exponent is 1. Okay, moving on for number 5, I see I have a 4 and a negative 3. So those bases are different. So I'm just going to do our regular multiplication with that, which is negative 12. And then I do have the same base of an x to the 4th and x to the 3rd. So I'm going to keep the base and add the exponents. Oops. So that was x to the 4th. They're both x to the 4th, so that's x to the 8th. And then there's nothing to pair up with the y's, so I just bring that along. All right, moving on to number 6. The 8 and the negative 2, those are different terms. So I'm going to do regular multiplication there with those. So 8 times negative 2, a positive times a negative. It's going to be negative 16. And then my a's are the same. I'm going to keep the base and add the exponents. So that's a to the fourth. And then there's nothing to go along with the b, so I'm just going to bring that along, b to the second. Okay, so when our bases are the same and we're multiplying, we keep the base and we add the exponents. The next set, from 7 to 12, I notice that we have the double exponents. This is the power rule, power of a power. This is where we keep the base and we multiply the exponents. To show you what this means, in parentheses, 3 to the second power would look like that, but there's 4 groups of this. So there would in all be 2, 4, 6, 8 threes, 3 to the 8th. Or my shortcut is keep the base and multiply the exponents. Okay, so let's apply the shortcut for the next one. We're going to keep the base and we're going to multiply the exponents. Okay, keep the base, multiply the exponents. Now, you do have to pay attention to all of the terms that are in your problem. So for here, we have 2 terms. We have the 8 and we have the m. The 8 does not have an exponent. Remember, no exponent is an exponent of 1. So I'm going to keep the base and multiply the exponents. Keep the base and multiply the exponents. So I get negative 8 to the 3rd power and m to the 6th power. Let's see that again for number 10. It's very similar. The 4 does not have an exponent, but I do have 2 terms in here. So I'm going to put an invisible 1 there with the 4, and I keep the base and I multiply the exponents. I keep the base and I multiply the exponents. So I get 4 to the 3rd, m to the 9th. Okay, moving along. Oh boy, there's 1, 2, 3 terms on this one. I'm going to put my invisible 1 there. I'm going to keep the base, and I'm going to multiply the exponents. Keep the base, multiply the exponents. Keep the base, multiply the exponents. So I get negative 6 to the 3rd. 0 times 3 is 0. And 4 times 3 is 12. However, ding, 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 anything right here to the 0 power is 1. So our final answer is 6 to the 3rd, v to the 12th, negative 6 to the 3rd. All right, moving along. 3 terms in the next one, so this 4 goes to each term. And if there is no exponent, I put 1s in there. So I'm going to go keep the base, multiply the exponents, keep the base, multiply the exponents, keep the base, multiply the exponents. Okay, so this is going to be 6 to the 4th, y to the 4th, x to the 12th. Okay, so if you see a power raised to another power, you keep the base and you multiply the exponents. For this last set on this front page, these all look like division problems. And we learned if we're dividing and the bases are the same, we keep the base and we subtract the exponents. Okay, that's when the bases are the same. So looking at my first example, these bases are not the same. But I can divide those just like regular numbers. 4 divided by negative 2, which is negative 2. For my rule, I'm going to keep the base and I'm going to subtract the exponents. So my final answer is x to the 1st. negative 2 and x to the first. For the next one, these bases are not the same, but I can simplify that. I can do a negative and a negative is a positive, and then 2 over 6 can simplify or reduce to 1/3. And then I'm going to keep the base, the same bases, and subtract the exponents. Remember, when there isn't an exponent, that's an invisible 1. So I get 1/3 and then x to the second power. Okay, looking at number 5. Let's see, I'm going to put an invisible 1 by that n. Nothing pairs up with that 5, so I'm just going to keep my 5 there in the numerator. For my m's, I can keep the base and subtract the exponents. And for my n's, I keep the base and subtract the exponents. Okay, so I get 5 m to the 0, because 3 minus 3 is 0, and n to the first power. And then, alert, alert, we learned the exponent rule that anything to the 0 power is 1. So my most simplified answer then would be 5n to the first power, which is the same thing as 5n. Okay, and the last one in this set, let's see, we have just a singular 5 there. It doesn't match up with anything else, so I just keep my 5. The y's don't have exponents, so we learned that if there isn't an exponent, that's an invisible 1. So my rule is when I'm dividing and the bases are the same, I'm going to keep the base and subtract the exponents. And then for the x's, I'm going to keep the base and subtract the exponents. Okay, so this becomes 1 minus 1 is 0, so y to the 0 power. And 4 minus 0 is 4. And then just like the last one, anything to the 0 power is 1. So 5 times 1 is still 5. So that y becomes 1, which makes it kind of go away. Okay, so if we have a division problem with the same bases, we keep the base and add the exponents. Anything to the 0 power is 1. And remember, if there isn't an exponent, you use a 1 as the exponent. Okay, side 2, we're going to use exponents to condense the expression. Okay, so you're just going to count them up. How many a's do we have? 1, 2, 3, 4, 5. We have 5 a's, so that can be condensed to a to the 5th. And then we have 2 b's, and we have a c. Okay, and if you want, you could put the 1 there, or an exponent of 1 can be just left without the exponent. How many 3's do we have for the next one? Just count them up. 1, 2, 3, 4, 5, 6, 7, 8. So the condensed version is 3 to the 8th power. Okay, next we have a mix of m's and n's. How many m's? 1, 2, 3, 4. So m to the 4th. And how many n's do we have? 1, 2, 3. N to the 3. And for the last one, we have 4's and we have 2's. I'm gonna do the 2's first since they're smaller than the 2. So you could do it either way. There's 2 to the 4th power and 4 to the 3rd power. Okay, so that is that for those ones. Just condensing. Okay, the middle section on the back is going the opposite way. We're going to fully expand. Okay, so that looks like this. A to the 5th would be A times A times A times A times A. B to the 2nd, B times B, and then there's a C. That's it. We're just going to fully expand it, stretch it out. For number 2, we have 5 of these. Okay, so we're going to go Negative 8 times negative 8 times negative 8 times negative 8 times negative 8. And I'm going to keep the parentheses in there to show that that negative carries along with each base. All right, 7 to the second power, that just means there's 2 of these. Fully expand it. And the last set, let's expand all of our letters. Okay, so m to the 5th, 1, 2, 3, 4, 5. N to the 3rd, 1, 2, 3. And p to the 0 power, well, anything to the 0 power is 1. So that's just a 1 there. And I don't even need the 1. I can just get rid of it. So that would be fully expanded. Okay, finally, we're going to identify the base, identify the exponent, and then we're going to find the value. We'll probably need our calculator for this part. Okay, so the base is this bigger number. So our base in this one is a negative 3. Our exponent is a 6. And then the value, negative 3 to the 6th power. Okay, so we're going to actually do that. You can use the caret key on your calculator. So we're going to go negative 3 to the 6th power. And let's make sure we include our grouping symbol so that negative carries along as 6 times that we need it. Okay, so I'm going to punch that in. Negative 3 to the 6th power is a positive 729. Now, if you didn't use the grouping symbols, the parentheses, then you probably got a negative for your answer. But the correct answer is positive. So double check that. These grouping symbols here, those actually matter. Those show that that negative carries along each time. Number 6, our base is 12 and our exponent is 4. So then I'm going to go in my calc 12 to the 4th power. So 12 caret key 4, which means 12 times 12 times 12 times 12. And we get 20,736 for the value. Okay, next up is 17 to the 3rd power. The big number is the base, and the little number is the exponent. And then we're going to use our calculator, 17 to the 3rd power. 17 to the 3rd power, 4,913. And then the last one, let's see, our base is that negative 2, and I notice I'm going to use those grouping symbols because that matters. And our exponent is 9. So then in my calculator, I'm going to go negative 2 to the 9th power. I'm going to use those grouping. I have them on here available, so I'm going to use them. You can find them right above the 8 and 9 on your calculator. And we do get a negative 512 for that one. Okay, see us if you have any questions or there's certain ones you weren't sure about.